thanks a lot for having me. I'm very happy to be here. So my last time in AMSE was for my flyout in 2019, so the context is very different, but hopefully less stressful, I don't know. But so I'm going to present this joint paper with a great team of co-authors. Kind of the follow-up of my job market paper of the time on teacher assignment. So I'm going to talk about this problem of reassignment under distributional objective. And so the motivation is, so hopefully we are in France, so I don't need to motivate too much the importance of centralized assignments, but that's something that exists in many places of the world. So there are many applications in which you want to assign and reassign workers in a centralized fashion. And so the important point is that in this type of market, you have senior workers who are currently employed somewhere and would like to transfer. Right? And I'm going to use the main application of the paper is going to be on assignment of public school teachers using French data. So you have teachers who are currently teaching in the schools and they ask to transfer to another school. And you have some other teachers who are newcomers who don't have any position yet and they need their very first assignment. But you have many other examples. So there is a nice paper by Modibo CDB on police officers' assignment in Chicago. You have the historical matching example of doctors to hospitals, which is also centralized in many countries. There's a nice paper by a student of Alros on tax administrators in India, where the civil servants are also assigned through a centralized system. I'm going to use the terminology teachers because that's our main application of the paper, because we have data. And there is also another interesting application where it's harder to find data, but exists a lot, is in the private sector, what they call job rotations. So think in large companies like Total, for instance, they have many branches all over the world, and they have this internal assignment of workers, which is not a standard market. They ask to transfer to another branch and so on, and they have there is some consulting firms that are specialized in HR to try to design this kind of internal reassignment. So you can also think about the model I'm going to present as also an application of this type of things. And the common feature of all this example is going to be one large employer. So it's going to be centralized, who is in charge of assigning the jobs to the workers. And workers have preferences over jobs. Employers have distributional objectives, and I'm going to be precise about what it means in the paper formally and also in our application. And the important point is there are senior workers who are currently employed, and you cannot force them to leave their position. So they are free to participate. So think about public school teacher. I'm currently teaching in a school. If I don't want to move, I can stay there forever, and I'm going to teach in this school. So participation in the reassignment is not mandatory. And of course, it's going to be a matching paper, so I'm going to abstract away from wages and clearing and transfer. And so typically, in this type of centralized public assignment, you have a fixed pay scale that depends only on characteristics and your seniority. And typically, you don't use transfer to clear the market. Of course, I'm not saying that transfers are not important to address some of the policy problems I'm going to present today, but think about what I'm doing as like fixing preferences and transfers and what we can do within this framework. And of course, in the broad policy question, transfers also come into play, but I'm not going to address this in this talk. Okay, so I'm going to set this. Yes.
Are you going to tell us something about participation? Are you going to calculate the welfare loss of not forcing people to participate?
So I'm going to take this participation as a given. So I'm not going so I'm going to impose in the design of the mechanism that you cannot get something worse than what you currently get. So I'm going to impose a participation constraint, like in a contract theory setting, you know, you always get something better than your outside option, and your outside option, if you are currently employed, is your current position. So I'm going to impose that in the design of the mechanism. So participation will be fixed through these constraints.
But this can come because I decide not to participate, or because I can participate but I have a veto, however, over the offer, and could always reject an offer.
Sure. So here I'm going to be agnostic on the implementation of this. So by design in the French system, it's embedded in the mechanism that I'm never going to have this decision whether to refuse or not, because I'm never going to have an offer that is worse than my current. I'm going to report a list, and this list is by design my preferred options to my current one. There was another question here.
It's related. In some of these contexts, people can be forced to move, right? So military, for instance.
Yeah. judge also. There are some examples of this. So I'm not going to address this, but
I guess it's easier from a matching point of view.
they are going to be, so in the model, it's going to be relaxing the participation constraints. So in the data, I'm not simulating this, but it's going to help a bit. I'm not going to have precise simulations on this. You can incorporate this kind of constraints in the model. You just relax the participation constraints, basically, for some agents. But here, I mean, in the teacher context, there is this constraint that I need to, you are guaranteed free to participate or not, but you are right that in many other applications, you can be forced to move. So one example I had is judges need to change assignment every 3-5 years or change. So that's going to be another type of things. Yeah. Okay. So in terms of distributional objective, so what we have in mind is that the policymaker will have some ideal distribution of teachers in the geography in France, but this can be in conflict with the preferences of teachers themselves, and you have this tension between what the policymaker would like to do and what people want in terms of preferences. So here it's the map of France. So the darker area here, the higher the share of disadvantaged students. And here is the distribution of the ratio of old teachers over young teachers. And so it's just to illustrate that usually, like where teachers want to go, like the older teachers tend to shy away from these high disadvantaged regions. And as a policymaker, you would like to distribute more of these experienced teachers in the country, basically. So that's going to be the broad motivation of the constraint we are going to impose in this design. And so the first contribution is to propose a new mechanism which, so it's going to be centralized matching problem. So I'm going to have a centralized algorithm. You report me your preferences over the schools. I'm going to impose some truthful constraints. So I want you to report your true preferences over the schools. And I'm going to, so there is a status quo matching, which is going to be the outside option. Some teachers are currently somewhere. Some teachers are new. Some positions are vacant. And I'm going to reassign and assign these teachers with some distributional objective in mind. And I'm going to give more, I'm going to give more detail about how we model this distribution objective, but the goal will be to not increase inequalities on the distribution of teachers in the different schools. Okay, I'm going to be precise what I mean. Basically, teachers are going to have a type which in the data we take as experience, and I want to be careful to not increase the inequalities of distribution of experience in teachers in the schools. Okay. I'm going to be more formal on what I mean by this. Yes.
So this is static. Somehow the preferences and this matching is only going to take one.
Exactly. So here it's going to be modeled as a static problem. That's one of the drawbacks. So I will need more data to get the full dynamic. Here, the application I'm going to use in the data is the assignment not of teachers to schools, but teachers to academy, to regions. It's a moment where teachers rank academies and they are assigned across regions. And typically, they move only once or twice in their career across academy. So then the exact counterfactual, so I'm going to simulate, so it's going to be mainly a theory talk. I'm going to use simulations based on data. For the exact policy counterfactual, I will need more data to push a bit further the simulation and the policy side. But you're right that in the long run, I would like, that's a current project we have, trying to get more data for the dynamics. But you know, as a rough first order approximation, because at the regional level, there is not much dynamic going on. You move at least once. You could say it's okay to do the static version, but that's definitely one of the drawbacks of this. Okay. Okay, so let me dive into the model to precise what we have in mind. So there is a finite set of teachers, and each teacher has an observable type, theta. And so to fix ideas, that's going to be the example we use in the data part. Think about thetas are the number of years of experience of a teacher. And theta, apparently, is the object you want to distribute. That's the object on which you have distributional objective as the policymaker. You want to be careful to not increase inequalities with respect to this distribution of thetas, which are so to fix ideas, think about experience, but of course, you may argue that experience is not a good measure, it's not what I want, but you know, as a policymaker, fix any observable type that you think is important to distribute teachers, and that's going to be your theta. And in the data, we use experience as a proxy of quality of teachers. So it's going to be order from the least experienced to the most experienced teacher. You have a finite set of schools. So again, in the data, I'm going to use regions or academies. So there are big sets, right? There are going to be regions. And each school has a certain number of available seats, QS. And as a standard two-sided matching model, teachers are going to have a strict preference relation over schools. So that's where the static part is coming. So preferences is going to be one shot over the schools I'm going to rank today. So in the current system, I need to rank the academy or the schools within the academy in the second step, and I'm going to be assigned based on this reported list of preferences. So far, it's a typical two-sided matching model. If you have done the 101 matching, it's going to be two-sided, schools, teachers. Teachers have preferences over schools. And now I need to precise what are the preferences of schools or the policymaker over teachers for the assignments. And so before doing that, so let me introduce some standard notations. So what is a matching? A matching is just a map that tells where each teacher is going. So you know, teacher T is going to this school, or can be unmatched also. You can have an empty school. And the important point of the model is there is a statu quo matching omega, where people have currently a position somewhere, sometimes empty. I'm a new teacher, I don't have a current school, but some teachers have a current assignment of a school. Okay? And that's going to be important as a constraint for participation. And so what is a mechanism? I'm going to think about algorithm or mechanism. It's going to be a map from teacher preference, all the primitives, but the important primitive that is private information is going to be teacher preferences to matchings. Okay? I'm going to take as an input teacher preferences and output a matching. So first, two standard requirements that are very, very natural. So individual rationality, or you can call it participation constraint as well in contract theory, for instance. I need to get something that I weakly prefer to my statu quo. So if I'm currently employed in a school, I'm going to get a school that I weakly prefer according to my preference ordering than my current school. Okay? So you cannot force me to accept something that I prefer strictly less than my current school. Okay? Yes?
For newcomers, it's just like anything?
So for newcomers, so in the model, newcomers are going to rank schools and the empty school, which is the outside option for the model. So I'm going to guarantee something better than the outside option. In practice, the outside option is leaving the profession, so you quit the profession. In practice, what they do, and it's going to be important for some part at the end, you will see, is that you are civil servant, you need a position, so they are going to complete your preference list so that you rank everything. So there are 31 academies in France, so if you rank 5 of them, they are going to complete your lists, and the rule is deterministic and known by everybody. They are going to take by increasing distance from your first choice. So they are going to take all the remaining academy, they are going to rank them in increasing distance. So if you are from Marseille, then they are going to put the academy the closest to the academy of, I don't know what's the academy of Marseille. So you see what I mean, Bouches-du-Rhône, probably. And so they are going to...
The question of participation, I guess, back to Cecilia's point, is also entering or not this kind of job, and this completely depends on the first allocation.
Yes, so I'm going to be completely agnostic on that, but so I don't have. So it's a very, very interesting question. I would like to do more on this. So currently we have more data on the dynamics of people currently in the job, because it's administrative data. I can follow people, see their preferences over time. But there are very few data. It's very hard to get data on the extensive margin of entering the profession. And it's very hard. I mean, you will need surveys. You will need to identify. There have been some works that have tried to identify the potential sets of people who can join the profession. But that's a very important topic. So in terms of surveys, there are anecdotal evidence that indeed the type of assignment they will get is also an important point in their choice to join the profession. So it has changed over the recent years, but to give a rough idea, in the US, in the first 5 years of teaching, there is 40% attrition in the teachers entering the profession. In France, it has increased over the past years, but historically it has been very low, less than 5%. And I think it's because we have troubles to attract ex ante, because people know that they are going to go to Créteil for their first 5 or 6 years of assignment, and so they don't enter ex ante. But once you enter, you know exactly the type of typical path that you will do within a field, and so then people decide. But that's a very good point. I don't have data on this, but that's an interesting. Yes?
I know it's pretty restricted, but how does the outside option of private schools factor in?
So in France, if you want to teach in a private school, you need a different certification. So there is one certification for public school, one certification for public school. It's a national competitive exam. It takes 1 year to get. If you get the certification for public, you cannot go to the private without the extra certification for private. And it's usually there is little mobility between the two. So recent years it has changed a little bit. People have been going a bit more to the private, but usually they choose ex ante whether they want to go private or public, and once they are in it, they rarely change between the two. So there is little mobility because you need to pass this new certification, which is an exam to prepare an additional year and so on. So there is in France little mobility between the two. Okay. Okay. So individual rationality is going to be a constraint on the mechanism. So I repeat, you cannot get something worse than your current assignment, strictly worse than your current assignment. And the second desiderata is strategy proofness, which is I want you to tell the truth. So you have a true ordering of preferences over the schools. I want you to have a dominant strategy to report this true ordering. So dominant strategy is very simple. Whatever the others are doing, I just always want to give my true ranking, independently of what the others are doing. Right? So it's stronger than Nash for the people. So that's the typical desiderata you impose in this design. So 2 standard properties. And now I'm going to describe the main objective on the school side, which is the main innovation of the paper. And so roughly speaking, the objective will be to reduce inequalities across schools. So I'm being very informal here, and I'm going to be more precise. And subject to these constraints of reducing inequalities, it's going to give me, so I have a statu quo with a given inequality across school. I want to have all my matchings that I want to attain are the matchings that are going to reduce inequalities with respect to this statu quo. And within that set, I want to be efficient with respect to the preferences of teachers. So so I don't want another matching that also reduces inequalities with respect to the statu quo and make all teachers better off. Okay. So I want to be on the Pareto frontier of this constraint of reducing inequalities. Okay? Yes?
So in the model, there is no school that needs more experienced teacher than...
So here I'm going to design endogenously the preferences of schools, and you will see the way I design them. Okay? It's going to be a design of the policymaker here. So some schools will want to increase experience, some schools will want to decrease experience. And the global objective will be to reduce inequalities. So typically the rich schools who have already a lot of experienced teachers, I would like to reduce the experience in these schools, or regions, because that's going to be my main applications. And the schools that are poor in terms of experience, I would like to impose the objective that they increase their experience. That's going to be roughly what's going to happen. And so let me be formal about what I mean by inequalities. So I have a matching. So what is a matching? It's a combinatorial object that tells where each teacher is going, right? And so I need to decide this permutation of where each teacher goes in which school. Given their experience, a matching is going to induce a distribution of experience in each school. So this object's like, once I decide a matching, these objects here are distributions. So school 1 is going to be this distribution of experience, school 2 is going to be get this distribution. So these objects are multidimensional, right? It's going to be counting the number of teachers of each type in each school. And then I'm going to plug this distribution through an object f that transforms a distribution into a real number. So this object, we call it a statistic. So think about transforming a distribution into a mean, for instance. So for each school, you are going to compute the mean experience induced by the matching, and you are going to get the mean experience in each school. And on this vector, then I can talk about inequalities, right? Interpret the mean as the income of the school, and then I can plug any inequality index that's your favorite inequality index, Gini, ratio of top 20, bottom 20%, and I'm going to measure inequalities with respect to this vector of real numbers. So the sequence is matching induced distributions and transform into vectors through a statistic. And once I have a vector of statistics, I can calculate inequalities using an index that you have fixed. Okay? And so the objective is going to reduce this measure with respect to the statu quo. The statu quo is giving a distribution of a given vector of mean experience in schools, and I want to decrease this objective. Right? I want to decrease inequalities. Is it clear? Okay, so this is fixed by the policymaker. Okay? You fix a statistic, the way you you measure this object, and then you fix an inequality index, and I want to always reduce this object. Okay? Yes?
So I'm just wondering to which extent you could have a type that is multidimensional and still be able to build indices the way you have.
So I don't know, you will see the way I design the mechanism because the unidimensionality of the type is important. So you will always need to have some measure that transform multidimensional in one ordering over types. Okay, at the end, schools are going to compare teacher by teacher, so it's going to be a linear ordering over unidimensional objects which are teachers, in a sense. So you need to transform, in a sense. It can be a convex combination of whatever. It can be value added if you want, maybe, if you want to measure value added from a multidimensional thing to a one number, which would be the value added of a teacher. Yes?
So it could be that your proposed mechanism is not parallel-octable from the school's perspective. What I'm trying to say here, I mean, I understand that schools don't really have preferences here, but it could, if you imagine the richer world where they did, it could be that inequality in my school increases, but that might be like beneficial for society or for the total amount of inequality.
So like you said, I'm not going to talk about preferences of schools because here it's designed by the policymaker. So you are totally right, and it depends in which world you are, whether you are in the decentralized world, where like in the US or some Northern European countries where the market is decentralized, the principals have a say in the recruitment of teachers. So here I'm not going to do that because that's not the application. But in a sense, in France, you have two levels of assignment, the academy and then the school level. And here I'm going to do simulations at the academy level, which I think is a little bit less, you can think about having some distributional objective at the academy level and still let the school choose in some systems. So in a sense, it's okay. But I agree that here I'm implicitly assuming that schools have no say in your assignments. Right? Yes, yeah, sure.
The inequality index that you have doesn't really care about the within school inequality, right?
No, exactly. It's going to be only across schools. And so I don't know what to do within school. I'm going to tell you what's the property now. So the statistic is going to be, my requirement, it has to be increasing in first order stochastic dominance. So mean quartile is going to work. So if I shift this distribution up in the first order stochastic dominance sense, I need this statistic to increase, right? So the mean, any quartile will be okay. The variance, which will measure inequality within school, is not first order increasing in first order stochastic dominance. So that's going to be a statistic I cannot use. And for inequality index, I'm going to use symmetry. So two schools that are identical in size, if the name does not matter. If I permute their value, it's going to not change the value of inequality. Continuously differentiable almost everywhere. And I don't need this property for the main theorem, but to interpret it as an inequality index, all inequality index have this property that is called shared convexity. So it's a form of convexity that says if my vector becomes more similar, then the function increases. Right? So typically, the Pigou-Dalton principle, where I take from the rich and I give to the poor, must increase the value of the function. Right? That's going to be the mathematical property that you need. So any inequality index, the top 20, bottom 20 ratio, Gini index respect all this shared convexity notion. So that's going to be the property we are going to use. So recall our objective. I want to decrease this object after reallocation. That's going to be my constraints. Yes?
Suppose you want to put experienced teachers in schools in poor neighborhoods. I don't know whether it's the actual objective, but if you want to do this, then it's not necessarily aligned with what you're doing, right? Because in your case, you really want to spread out the experienced teachers everywhere. But if one academy is problematic, you would want to put more experienced teachers there.
So actually, I don't need this. So any function that is symmetric in C1, the design I'm going to propose is going to work. So I don't need to have a function that targets equality, even though in the application we use this. So in particular, I think there is a way to, if you want a dummy variable that increases only by counting the poor neighborhood number of experienced teachers, my construction is going to work. Okay, but you will see when I present the material.
That inequality
Exactly. That's terminology for motivation because that's what we do in the data. But any function that respects this will work in our model, and you will see exactly after. So it can capture. So I'm not sure it's going to be always interesting because if you want to increase experience everywhere, at the end you don't reassign types across schools. You are just going to exchange within types. So it's not a very interesting mechanism. But the interesting part is when there are schools that you want to decrease, schools you want to increase, and you are going to make exchange between them. So that's going to be the important thing. Okay. And so the objective is we want to reduce inequalities. So formally, I want to decrease this index with respect to the statu quo under individual rationality and strategy proofness. And subject to that, I want to achieve the Pareto efficient matching. So I don't want another matching that also reduces this index and makes all teachers better off. So in a sense, I maximize efficiency measured by the ranking of teachers under the constraints of inequality reduction. Again, that's the way you can think about it. So bad news, impossibility result, you cannot have all these properties at the same time. So if I want to decrease an arbitrary inequality index that is strictly Shor-convex in this example, and there is no mechanism that's going to be individually rational, strategy proof, efficient, and reduce inequalities. Okay, so I cannot do it directly, so I need to find a second best or an alternative way to achieve this objective. So that's going to be the first statement. How do you prove this type of theorem? It's very easy. What I tell my students is a good matching person is someone who builds good example. So you build an example, 2 schools, 4 teachers, you can compute all the matchings on the Pareto frontier, and then any mechanism is going to pick one, and every time you pick one, you show that someone can deviate and force you to take another one that will make the deviation. So it seems a very impressive proof, but actually it's through examples, right? And so doing good example is an important thing. Okay, so we need an indirect way to reduce inequalities. Why is it hard to have strategy proofness at the same time and efficiency? It's because this objective of reducing inequalities is kind of a complex global objective because I'm going to compare schools like across schools, right? And it's going to create some dependencies across the schools which makes the incentives hard to respect. That's the rough intuition of this impossibility. And so we are going to do it in an indirect way. So instead of working directly with the inequality index, I'm going to impose constraints school by school and treat schools independently from each other with the objective at the end to reduce inequalities. And the intuition of how it works is if you want to reduce inequality, you want basically to decrease the rich and increase the poor. Right? So I'm going to impose that the rich schools are going to decrease their experience and impose that the poor schools in terms of experience, I'm going to increase experience with respect to the statu quo. And intuitively, that should reduce inequality under some conditions. Okay? And so that's the intuition we are going to do. So you see, instead of treating directly the reduction of inequalities globally, I'm going to impose a constraint school by school. I'm going to say these schools are going to increase, these schools are going to decrease. And it's a school by school constraint. And this independence across school is going to make us have some positive results, basically. Okay, so now this is how we do it. So for each school, so maybe it's easier to show to a graph. So remember here, that's our statu quo matching. It induces some initial distribution of experience in each school. What I'm going to do, hopefully I try to design this to be the poor schools, like the distribution is more on the left. These are the relatively richer schools, the distribution is more on the right. So as a policymaker, what you are going to do is to fix an ordering, a priority ordering for each school. And the poor school, you are going to require that they increase their experience. So they are going to prefer higher experienced teacher first. And the rich school, you are going to do the opposite. You are going to make them prefer the low experienced teacher first because you want to decrease their distribution. And what you want to do is to impose the constraints that we call statu quo improvement, that once you do the reassignment, this distribution shifts in the first order stochastic dominant sense in the good direction. So the poor schools are going to shift up their distribution of experience, and the rich schools are going to shift down their distribution of experience. Okay? So that's the constraint. I fix this objective school by school, and I'm going to design a mechanism that's going to ensure that the poor school always increase their distribution and the rich school are going to always decrease their distribution. Okay? So that's going to be a school by school objective. Okay, so far? Yes?
Why do you not want the distributions to match the entire distribution of teachers in terms of experience? Like you could have some search time distance for each school to the global distribution, and instead of having a translation of this distribution, you would have a shift on higher moments as well.
So you will see, so I'm going to show that this is sufficient to decrease inequalities. So I'm going to achieve my objective with respect to this inequality index. You are describing here a different objective. So here, here in a sense, I'm constrained by the statu quo. If the statu quo is not already the distribution of teachers, so that's where the initial match matters, right? If I can force teachers to lose their initial ownership and reassign everybody, that's what I would like to do. Then I will do uniform assignment, everybody in the same. But here there is the statu quo that might be very unequal, and actually in France it's very unequal starting, and so you are constrained by this initial match basically. Okay. Okay. So we are going to build a mechanism that is going to be strategy proof, individually rational, and statu quo improving. And by statu quo improving, I mean for any given fixed objective for each school, it's going to require that the distribution shift in the correct direction, in the good direction. And let me give you, so through an example how this mechanism works. So we call it statu quo improvement cycle and chain. So if you are familiar with this literature, it's going to be a top trading cycle-like mechanism. So you are going to have a graph where people will point and you will allow exchanges of people of seats. Right? So let me do it through an example. So this is the example. So you have 3 types of teacher. So the types are the experience. High experience, medium experience M, and low experience L. Here you have 4 schools, S1, S2, S3, and S4. So these circles here are the initial match. So teacher H1 and L1 are initially in S1. So H1 is type H, high experience. L1 is type L, low experience. Same here for S3, same for S2. And S4 has just 1 vacant seat. Okay, there is someone will retire, then there is an empty position. And teacher HN is a newcomer with no position. So for the sake of the example, I'm going to assume is high experience, but it can be arbitrary. Just a comment on this. In the data, we do have positive experience newcomers because there are teachers who left the profession, worked at the ministry, did something else, and then came back. So I think in my data is 7% of the newcomers who don't have an initial position ownership have positive experience. So you can account for that in the model. Okay, so you start, first step of the mechanism, you build a graph. So what is a graph? It's just nodes and arrows. Right? So the nodes are going to be the teachers and the schools. And I'm going to design the pointing and the arrows in this mechanism. And so the first rule of the mechanism is, the objective. The statu quo is this, and I'm going to assume that your objective as the policymaker is to increase the experience in school S1 and S2 and decrease the experience in S3 and S4. Okay? I fix this objective, and I want to design the mechanism on this. So first rule is the schools always point to their worst type teacher. So if you want to increase experience, you need to point to your low experience teacher first, right? If I want to increase experience in my school, I need to always get rid first of my lowest experience teacher. And vice versa, if I want to decrease experience in my school, I need to get rid of my high experience first, if I have multiple teachers. So that's the first rule. First pointing rule, schools always point to their remaining worst teacher in terms of the objective. So here in that case, this is it. The second typical thing is if you want to keep incentives in line, you need to try to give to each teacher his favorite school at any given step, but favorite under the constraint of under the constraint of this distribution here. So meaning that some teachers, so take L1 here, he prefers S2 the most. The problem is that if you send L1 to S2, you are going to decrease the experience in S2, and that's not the objective for S2. S2 needs to increase experience. So this exchange, L1 going to S2, is infeasible with respect to your objective. So what you are going to do is you are going to forbid teachers to point to their favorite school if it violates your constraints. And so typically, this L1 at the first step is going to be forbidden to point to school 2. And you are going to keep incentives in line because this is exogenous from the point of view of L1. He has no say with respect to whether he can point to S2 because this is given by the primitive of the model, the statu quo and the types of people. So that's the first thing. Okay, so given this constraint, you check that everybody can point with respect to the constraint. You make people point to their most favorite school given the constraint. In this example, only L1 is forbidden to point to his first choice. You are going to have this graph, and what you do is you check cycles in the graph. So here you have one cycle here, and you are going to tell each teacher is going to be definitely assigned to the school he's pointing to. So here you clear these teachers. So you see H3 goes to L1. You update the distribution that you are going to get in the school, and you continue with the graph. Schools are going to point to the remaining worst teacher. So pointing again, you get this graph. Teachers are going to point to their favorite feasible school. At some point, it might be the case that there is no cycle anymore. If there is no cycle, it means that there is a chain somewhere. So what is a chain? It starts from a new teacher. It goes through some schools, replacing some teachers, and it ends at a vacant seat. This, you implement the chain. So teachers are assigned to the schools they are pointing to. You update the distribution. Schools point to their remaining worst teacher, and this is the key part for the efficiency part. So here, look at this example. S1 has currently a H1, and the objective of S1 is to increase experience. And here, M3 would like to go to S1. So in theory, if you assign M3 to S1, you will decrease experience in S1. So that will not be feasible with respect to your objective. But what you have is that in the previous step, S1 already exchanged, so what was the student? Here. Already exchanged a low experienced teacher with a high experienced teacher. So actually, you can do this exchange here. You can authorize this exchange because if you switch these positions, you will be back to the previous distribution of the statu quo, and this is feasible, right? I haven't changed anything with respect to the statu quo. So the key part of the mechanism is the pointing at a given step depends on what happened at the previous step. So maybe at a given pointing, you will think that you need to forbid this pointing, but because in the past you have a buffer, you have accepted more high experienced teacher than you had initially, then you can allow low experience to join. Right? And that's the buffer that you need to check in the mechanism at each step. So that's the rough intuition of how it works. So there is school pointing, you point to the lowest ranked teacher first. Teacher pointing, there is this counter that checks the buffer of experience you have to authorize teachers to point. And you have these chains to match empty seats and newcomers. So that's the rough intuition of the mechanism. And so this mechanism SICC, you can prove that it's strategy proof, and it's going to be individually rational and statu quo improving with respect to the fixed ordering school by school that you have fixed, right? And it's going to be constraint efficient with respect to the statu quo improvements. So that's the algorithm we propose. Any change in any of this rule of pointing is going to break one of these properties, either strategy proofness, either constraint efficiency, or something else. Okay? Yes? So far I haven't talked about anything about inequality reduction. Here I have fixed an arbitrary objective school by school, and I just designed a mechanism for this objective. And now in the second step, I'm going to show how you can design the school by school objective to reduce inequalities. But the constraint I'm going to have is that I'm not going to be constraint efficient in a set of all the inequality reducing matching. In a sense, this mechanism is going to reach a subset of matching that are going to be inequality reducing, but maybe not I'm not going to be on the Pareto frontier of this original objective. That's basically it. But there is no mechanism that is strategy proof on this Pareto frontier. So it's I have a kind of second best result. You will see what it means. Yes.
So in the current strategy, the schools, they don't point, right?
You mean which current?
The current, you showed us what you refer there as current. I mean, what you try in what's happening today, the schools, they don't point on their teachers that they prefer.
Okay, so the algorithm they use today is completely different than this. So they are going to use a Gale-Shapley. So by the way, all of this is done through a computer in 1 second, right? You report the objective of the school, you report the list of preferences of students, and the algorithm is going to simulate this pointing. So it's not a physical pointing where people get contacted or so on. And the second comment is today they are not using at all this type of mechanism.
Okay, exactly.
Yeah.
So my point is that wouldn't the preferences of the teachers change if you show the system of pointing of the schools? See what I'm saying?
So here, so I get the result of strategy proofness. So the pointing of the school, the key point, it depends only on your observable characteristic, which is your type. So whatever is your preferences, you are not going to influence the pointing of the school. So by strategy proofness, you have to report your true preferences.
Right, but wouldn't my preferences change once I know the school pointing system?
So if everything is static and you believe that the preferences are exactly fixed like this with an ordering of school, it's strategy proof, so you don't have any change of preferences. You have the incentives to report your true ranking. In the current system, the mechanism they use today is also strategy proof. So you also have the incentive, if you believe in this static model, so we can come back to this critique, but I answered it before, that's not going to change anything. Then if you are in the dynamic and you believe that there are some multiple rounds of matching over your period, then that's another story in terms of what it means to be.
In reality, the preference of your school may depend on the current distribution of experience among schools. I mean,
Okay, so second implicit assumption, your preferences are fixed and exogenous and do not depend on the distribution of teachers within the school. So in the school choice literature, when you think about matching students to school, it's the assumptions of peer preferences. Here I'm assuming that there is no peer preference. Otherwise, strategy proofness has no meaning because your preferences is over ex post, and so that will be a different model, which is totally valid if you believe it exists, but I'm not modeling this. Yeah. Valid point, but okay. I don't know if it answers your question, but yeah. Okay. So that's the mechanism. And so how much time do I have? Sorry. So, half an hour. Okay. We're good. Thanks. Okay. So here you saw I started with this general objective of reducing inequalities. I showed you it's impossible to achieve, so I made a detour by fixing an objective school by school, designing a mechanism for this school by school objective. And now I'm going to come back to my original objective to show you that there is a way to design the school by school objective to decrease inequalities with respect to this index that I showed you initially. And so this is how we do it. So the first comment is I'm not going to be able to do it all the time, so it's going to work in a large market model with this observation. So there is a large number of teachers who do not apply for transfer. So 96.5% of the stock of teachers every year they are happy where they are not participating, right? So when you calculate the distribution of experience as a policymaker, you count this teacher in your mean experience, right? This is your stock of teachers. So that's the first observation. So the first observation is there are many teachers who are not going to move. And so whatever you do in your reassignment, you are not going to shift drastically the mean experience in the region. Right? So it's not because you reassign all the experienced teachers a given year to Créteil that Créteil is suddenly becoming the richest region in France in terms of experience of teachers. So that's the first observation, and that's going to be my large market assumption I'm going to show. So I need to account for non-participating teachers. Teachers who are currently in a school are not moving, and they count as when I calculate the experience of teacher. And so for a given school, or think about region is going to be my application. For a given region S, I'm going to have a number of experienced theta teacher in this region S. And what I'm going to do, and that's going to increase, so I'm going to index the economy by n, and I'm going to duplicate this distribution of non-participating teacher in each region. And so what's going to to do is going to imply that you are going to fix your set of reassignments, and the set of outside teacher is going to become increasingly big with respect to your reassignment, meaning that whatever you do in the reassignment, you are not going to shift the mean by much. That's going to be the implication of this assumption. Am I clear on that? So, okay, set of experienced teacher that is infinitely larger than your reassignment model. Okay, and the implication of this, which is what I need, means that if I reassign whatever reassignment I do, I'm not going to shift the mean experience by a lot. That's going to be the implication of this large market. Okay, and so this is the main proposition. For any generic Bayes economy, so with the distribution of outside teacher, there exists a way to design an objective school by school, such that in the large, if I increase school by school, then I reduce inequalities with respect to my global objective. So I have a way to design this school by school objective, such that I'm guaranteed that the inequalities will reduce with respect to my index that I fixed initially. So this global objective. Okay? And so this is how you do it. I'm going to do the proof because it's relatively easy. And so what you do is, so this is the limit, but what we do in the data is take your statu quo and take your statu quo vector of mean experience and partition the schools in two sets, the poor and the rich. What are the poor? They are the schools for which the derivative of your index for that school is negative. So what does it mean? It means that a school is poor if locally, if I increase a little bit the mean experience of this school, it's going to decrease the inequalities. Right? So that's the intuition we have, right? If I increase a little bit the income of the poor, I'm going to reduce the inequality. And the rich are the opposite. They are the schools for which if I increase a little bit the mean experience, it's going to increase inequality. So I want to do the opposite. I want to decrease the mean experience of these schools. And so this is the partition of schools. There are schools that are in L, schools that are in H. Generically, this is strict. If you have some schools that are exactly 0, we show that it doesn't matter where you put them, but that's a mathematical detail. And basically, what you are going to impose is you are going to say, these poor schools, you are going to impose that they shift up their experience. You are going to want them to have more experienced teachers. And this rich school in H, you are going to want to do the opposite. You are going to impose that they decrease their experience and shift down their distribution of experience. So that's the intuition. That's very intuitive what we want to do, right? You want to decrease inequalities. If I increase a little bit the poor and I decrease a little bit the rich, that should decrease inequality. That's basically it. Okay, but why do I need large market here? It's because this is only a local condition at the statu quo. Right? So what it says is like from the current situation, if I increase a little bit, then I'm going to guarantee that I decrease inequality. But it's not guaranteed in all matchings, right? It might be that at some point I reassign and the sign of the derivative change. What does it mean is that, let's say I take a poor school and the poor school becomes so rich that actually if I continue to put high experience teacher in that school, it's going to re-increase inequalities again. Because I've given all the money to the poor and the poorest become the richest and even richer than before, so the inequalities start to increase again. And so this is why you need a large market, is because I can create example in which you will have overshooting, basically. If I only guarantee that a poor school keeps increasing, at some point I might overshoot. That's the intuition of the... But this is where the large market kicks in. In the large, this derivative, because the index is continuously differentiable, because in the large, the mean experience, the vector is going to change by only an epsilon, I'm guaranteed that these signs are not going to change. Okay. Because the outside set of participating teacher is so large that whatever I do in the reassignment, it's not going to change the vector much by the statu quo, so these derivatives do not change. And so I'm guaranteed that I keep going in the right direction, so the index at the end will be guaranteed to decrease. That's the intuition of the proof. Okay. So, well, it took us a while to model this, and once we got the proof, we were disappointed because at the end it's easy. And I remember an interview by Cedric Villani that was saying in maths it's always like this because you believe that you have the hardest problem in the world, that you will be the smartest people, and once you solve the proof, you understand everything, so you find it too easy, and then you have a depression after finding the proof, and that's a bit the way it worked for us. Sorry.
Application we can check whether this works, no?
So I'm going to run the mechanism. I'm going to check ex post that indeed in decrease. Then what I will need to verify that it's exactly this condition, I will need to check all the possible matching and check that the derivative does not change, and this is very combinatorial. I cannot do it. But what I'm going to do is so let's go to the empirical side, but I'm going to mimic exactly this decomposition of schools. I'm going to run my mechanism, and ex post I'm going to see that indeed it decreases inequality. Right?
But you're not totally sure it will have worked.
Yes, exactly. But our intuition is that there is a large set of outside teachers, so that should work basically. And the inequalities are so large in France in the initial distribution that to get overshooting, you will really need to move Créteil as the richest school, richest region at some point. So this is very realistic.
Sure, but with schools,
I agree.
there are small numbers.
Exactly. No. That's why I think the academy assignment is a good application of this model. So if you have units that are small and that have only 2 seats and over 10 teachers, if you reassign a large share for a given unit, then indeed you might have overshoot. So this I agree. Okay. So that's the theory. I'm going to skip the literature and the theory, and I'm going to move to the empirical analysis. And okay, so this is our simulation. So we have data on the centralized French reassignment of teachers to regions, academy, 2013. So we are trying to get the new data, but with the past 2 years of change of government, it has been a nightmare. So nobody can sign anything, so we are just... and so I'm going to be very quick for the estimation, but what we do is we observe for this year all the ranking that teachers submit to the system, and the current system, it's not at all what we are doing. It's a Gell-Shapley, if you know what is the algorithm. There is a priority system that is based on a score that is mainly based on experience, and you use a stable mechanism. I'm not going to enter into the details, but basically what you can do, if you believe in the static assumption that we already discussed, is there are plenty of papers off the shelf that tell you how to estimate the cardinal utility based on the reports of people from this mechanism that is well known because it's used everywhere. And so we use the technique of some of our colleagues, Julien Combe, Gabriel Fac, and Ying He had a very influential paper on this estimation technique. And so basically you can, based on this mechanism, you can extract it's like a logit utility model. You're going to have a cardinal value for each school that depends on the region, that depends on your characteristic and characteristic of the region, plus a Gumbel shock. And once you get these estimates, I'm going to just redraw the Gumbel shock and do 1,000 simulation of these preferences. Okay? So I'm happy to talk about it offline, but I want to acknowledge the caveat of the dynamic. We already discussed it. Implicitly, if you believe that teachers have dynamic preferences, what I'm capturing here is also the forward-looking value of what they expect to get in the future if they change their assignment today. And this depends on the mechanism for the counterfactual, so that will be the caveat of this analysis, right? But we already talked about this. So we really would like to do the dynamic model, and hopefully if we have a stable government at some point, I might be able to get this data. But, so we do a separate estimation for tenured teachers, so people who have already an assignment, and newcomers who are the first to come in the system. And we take the 8 biggest fields. So think about a field as a separate independent market. So you have the reassignment for maths teacher, the reassignment for history teacher, history geography, for sport teacher, so on and so forth. So we take the 8 biggest field. We do the estimation field by field, and then we run our counterfactual for each field. So there is no, if you're a maths teacher, you cannot get assigned a position in history. So all of these are separated markets in the data. Yeah. And the final sample is roughly 10,000 teachers, so 55% of them are tenured, have an initial position, so the statu quo for them is they have a current school, and the rest are new teachers. Okay. And so...
in those figures you have the people who don't move as well, or those are only the
Yes, so what I'm going to do, so what I'm having, it's true that this is the old slides, but okay, story of the paper. First time we submitted, we didn't have the inequality thing. We just had the type by type. Then we simulated with the intuition of inequality, and we show in the simulation it was working well. Then referee 2 said, but there is an incoherence between your theory and your motivation, so can you link the two, right? We're stressed, so then we came up, that's why we had the first algorithm, and then I moved back to the large market, because that's what we did in the first revision. We created this new model to link precisely the inequality objective, and that's how we do it. So in the initial sample, we didn't have this outside teacher. Now with the new theory that we had, we needed to calculate this derivative, the outside, so we have access to this at the depth. You have the equivalent of the DADS, employer-employee data for teachers, so you can know in France all the distribution of each year of where teachers are. So what we do, maybe I'm not precise enough, what are the types here? Okay, let me do this and then I come back to the mechanism. So we are going to use as a type the experience, number of years of experience of teacher. So we are going to partition the teachers into 13 experience bins. So what we do is we do 0, 1, 2, 3, 4, that are each a separate type. So in the economics of education literature, you know that the value added is increased a lot the first 4 years of experience. Then it's very flat. And then recent papers show that it decreased a bit in the old age. So we do 0, 1, 2, 3, 4. Then we group by bins of 3 years. And we do 3 years, 3 years, 3 years, 3 years until the end. Then, it's just to illustrate the simulation. Then if I were to implement this mechanism in practice, I would be more careful. What do we mean? What is the type? And so on. So that's how we do it. And for that, we have the distribution of experience of all the outside teachers that year. So this we calculate, yes. And so in terms of simulations, I'm going to run our mechanism, and like Ian was saying, this is a large market result, so I don't have guarantee that the inequality index is going to reduce in this specific data. And I'm going to compare it to 2 benchmark mechanisms. The first one that we call TTC star is the same as our mechanism, except that we remove the constraint on the school side. So I just take into account teachers' preferences and I maximize their preferences without any constraint on the inequality and distribution. In a sense, is to see what is the cost of imposing this inequality reduction constraint. And the second one is the current system that is based on this Gale-Chaplet deferred acceptance for the people who know. And so we are using actually the actual priorities in the current system. So that's the actual assignment you will get with the current mechanism. Okay.
So that people got.
So because we have a bit of cleaning, it's not exactly the same, but it's almost the same, yes. Because they have a weird system for coppers that we remove. There is a few hundreds of them. We remove the overseas territories, so because they have specific rules for them. Their preferences is very particular in the small sets, so we do only the 25 academy of the metropole. So there are these kind of details that change a little bit, but roughly it's the same, yes. Yes, thanks. Going to be finished very soon. Okay, so that's the 3 mechanisms. So how do we do? So I had to change the slides, I didn't do it. So I need to fix a statistic and an inequality index. For statistic, we fix mean experience, but you can fix which one you want. And for the inequality index here, I wrote Gini because that was initial, but it's not true anymore. So we use the top 20, bottom 20 ratio, which is also one that is very used in the literature of inequalities. Why? Because the Gini index is not very sensible to the inequalities at the tails, So France is very unequal. So you have Créteil-Versailles that have a lot of young teachers. And then Rennes, Bordeaux, and south of France, Bouches-du-Rhône, have a lot of high experienced teachers. And then you have a middle ground of things that are a bit more equal, let's say. And so if you do Gini, actually, you are going to be very sensitive to the middle and very less to the tail. And this top 20, bottom 20 ratio. So what you do is you take the mean experience of the top 20% schools in terms of experience over the bottom 20% schools. And this is much more sensitive to the extreme inequalities. So that's what we use. But in the paper, we also illustrate with Gini, with the Atkinson index also, if you know it. So there are plenty of things you can do. And what do we do for the design of the objective of each school? We follow the proof, right? So what we do is we calculate the derivative of the top 20, bottom 20 ratio at the statu quo. It gives you schools that have strictly negative derivative, strictly positive. Actually, there are many of them that have 0 because they are not in the top 20 and bottom 20, but it doesn't matter where you put them, so we have some robustness, but it's not very important. And basically, the one with negative, so you can check, it's coherent with what we have in mind. The negative are the poor schools, so you have Créteil, Versailles, Amiens, typically, that are the 3 most disadvantaged academy in France that if you ask to the DEP, it's well known. And so it changed by fields, okay? There are 8 fields, so I give you an aggregate, but it can change by field. And in the rich school, you get typically Bordeaux, Rennes, Lyon in terms of academy, and also I think Academy of Bouches-du-Rhône is probably also here, okay? And what we do is we follow the proof. So the proof is telling you the poor school, you want to increase experience in terms of type. The rich school, you want to decrease experience. And then you run our mechanism, basically, and you check what's happening. So this is the table. So this is the value of the ratio. At the statu quo, it's 1.3588. So if you run our mechanism, indeed, it decreases inequalities. So, even if it's a small market, it works. If you were to remove the constraint on the school side, like you just maximize the preferences of teacher, this is the tension I was mentioning at the beginning with my 2 maps, you would increase inequality with respect to this measure. So there is it's a market where this tension exists. You cannot. It's important to put this constraint if you think it's important. And in the current system, the current mechanism, you do increase inequality by a lot. Okay. So I can compare. So now I have a different bunch of statistics. So this is the number of teachers who get a new assignment. So if you are a newcomer, it means getting an assignment at all. And by the way, we complete their preference list exactly like the minister is doing. That's the same rule. And the tenure teacher means you move away from your current assignment. So of course, imposing the constraint of inequality is reducing the number of people moving. It's a constraint, right? So if I were to maximize only the teacher's preferences, I would have much more mobility. And this is the current system mobility. So it comes at a cost. So I give you the cost benefit of these two measures. And so that's the type of, you can compare the distribution of ranks. So what you can show is our mechanism is better for new teachers and worse for tenure teachers, basically. So you have kind of statistic like this. And I want to show you, so this is the distribution of experience in the bottom 20, top 20 region. And you see, so the black line is the statu quo. So you go from high experience. So the bottom want to increase experience, so it's better to be on the left side here. And our mechanism is designed to shift up this curve, right, by design. So here it's coherent. Our mechanism does shift up. If you were to not have any constraint on the school side, you will not stochastically dominate. You would violate the constraint of stochastic dominance. Same for the top schools. You will assign way too many experienced teachers in the top schools if you were to not put the constraint of inequality. And it's even more striking on this graph. So these are the regions sorted by lowest experience to highest experience at the statu quo. And this is the change of experience between the statu quo and the mechanism. So if you were to not put any constraint on inequalities, this will be the gray line. So you will decrease the experience in the worst region, the poorest, and you will increase experience in the already rich region. But if you were to use our mechanism, this is by design, okay? By design, this school will increase and these schools will decrease. The rich school will decrease experience, the poor schools will increase, or academies, regions will increase experience. So that's very striking to see a bit the mechanism through which the inequality is reduced here. And in the last 5-10 minutes, I want to show a last very important point for the policy design. So there is an important cost that I was very quick in the previous table, which is this one. So this is the number of tenured teachers who move from the 3 youngest regions, so Créteil, Versailles, Amiens, typically. So actually, what you see is that in the current system, a lot of them move, because actually they get a lot of priority. You know, if you have teach 5 years of 8 years in a disadvantaged school, you get a bonus of priority in the current system, so they can move. But in our mechanism, by inequality reduction, nobody wants to go to Créteil, Versailles. So if you don't want the mean experience to go down, you need to keep this teacher, basically. And so that's a cost, right? You decrease by a lot the mobility. So if you think about the dynamic and the incentives, that might be a problem, right? You might want to increase this mobility because basically, if you enter Créteil-Versailles Amiens, this mechanism will stuck you forever there. I don't know, I don't have the full dynamics, but that would be the intuition. And so here, what we are currently doing, sorry, Paolo.
No, but even more, maybe it would, the reason why people go to Créteil-Versailles nowadays is to cool at this point. So you are killing the very incentives that deal with this. They start going.
So that's an open question. This I don't know. I will be curious to see in the data because the current system is so it's a very ladder. So actually 60% of the newcomers are assigned to Créteil-Versailles, and every year more than 50% of the tenure teachers move from Créteil-Versailles. So it's really like everybody wants to go to the good regions, but everything is full. So I don't know if the priority helps actually. I think mechanically I can write a model where that will be the dynamic. People, if everybody have correlated preferences, then everybody starts in Créteil because they have low priority points. They have no choice anyway, independently of whether they accumulate points or not. And then they wait for retired teachers to free space up and they move up. So that's an open policy question that is interesting, is whether these points actually help in choices. Or I can also show that the only thing that they are doing is create inflation in terms of cutoff. But maybe they don't matter. So that's an open question. This I don't know. Yes?
Don't talk here about monetary incentives. Is there any, because there are some?
So here, in 2013, there were none. In this disadvantaged region. So there are papers nowadays from INSEE that is trying to evaluate the Macron policy. I think there are papers in the US that show that the elasticity of wage for teachers is relatively low, like kind of very low. And they did a similar exercise in the US where they show that to really correct inequalities across schools, you will need amount of budget that are really high. So people are saying that there is a limit on what we can do. But that's definitely in the global policy perspective of education. I will not say that this is the only thing you can do. So monetary incentives are important, but that's also, yeah.
So there are monetary incentives in the sense that there's unlimited residence in France that varies from 0, 1, 3% depending on where
Yeah. So to come back to so what you are saying is whether I can estimate the elasticity of wage in this model when I estimate preferences. So here everything will be captured by the fixed effect at the region level that we have in the estimation. And if you try to disentangle the elasticity to real wages, then it's a typical I/O problem à la BLP, which is it's endogenous because prices are high because there are already a lot of demand there. So you will need some instrument to the structural model will not be able to disentangle fully a causal estimate, especially if you want to do counterfactual on the wage, right? Which is here in a sense I'm not touching the wage schedule, so it's fine to not estimate it. It's going to be captured by the fixed effect. But if you want to do counterfactual of the wage, you will need some kind of I/O techniques that have some shift share of or whatever IV that you could do because there will be prices are endogenous to the demand itself. So you have to be. So that would be my answer. Yes. Yes.
The inequality objective is not in terms of teachers' experience, but in terms of student performance. Would that still work with just some assumption on the effect of teacher experience on student performance?
So what I have in mind is the whole distribution story is indeed for students at the end. So what you can do is whatever type you believe is important for students, you fix it in the model and you will do the counterfactual. Here we did the easy version. We took experience just to illustrate. What I know from the economics of education literature is that value added will be the good measure for what you have in mind. There are very few observables that correlate with value added. There is a lot of unobserved heterogeneity across teachers. One of the only one that correlates is experience. And like I said, what you observe is like sharp increase in the first 4 years of experience, relatively flat, and a bit decrease toward the end. So that's the only thing I can say. So here, what I'm saying is like we took experience because it's known in the literature that it correlates with your value added as a teacher. But if you were to implement that in practice, they should be very careful thinking about what is the type that is important for the policy to distribute, right? That would be Okay, and I want to finish in the 3. So what we do here, we want to increase this number of teachers moving out of Créteil Versailles. So what we do is we note some 3 aspects of the current system. The current system, newcomers have to rank all the regions. Newcomers have low priority, most of them, because they have no experience, and the current priority is based on the experience. So what actually the current system is doing, it forces newcomers to go down in their list. It's as if you were requiring them to go to rank first Créteil Versailles, because there are no way they can be assigned first in Rouen, Bordeaux, or so on. And the third thing is that there is no constraint on the distribution. So typically, if you are an experienced teacher, you can leave Créteil and Versailles and be replaced by a newcomer, and that will decrease experience in Créteil Versailles, but there is no constraint in the current system. So what we do as a variation of our mechanism, we don't touch this, but what we do is like we force newcomers to rank first Créteil and Versailles, which is exactly what the current system is forcing them to do implicitly, because they have 0 priority, so they will be forced to go down in their ranking. And if they have to rank all the region, it's not going to affect strategy proofness, because it's an exogenous change that I'm controlling as the policymaker. And because you don't have a say and you have to rank everything, it's not going to affect your incentives in which order you rank the regions. So you still have an incentive to rank truthfully Créteil and Versailles and the other regions. The only thing I'm going to do is to take these 2 and move them up exogenously. So it's not going to change your incentive here. And if you do that, we call it SEC star, then you move to this number of teachers moving out of Créteil Versailles. And by design, because I'm not relaxing constraint 3, in the sense that I still impose the statu quo improving, I'm reducing inequalities by design, right? I'm still imposing that inequality reduce. And then what we are currently doing is to go more, can we push this number even more? And the only way to do it is to relax these constraints. In our mechanism, I will never allow an experienced teacher to be replaced by a less experienced newcomer. But if you relax this, basically that's what the current system is doing. It's telling you, okay, you have done your bagne at Créteil, you're allowed to move out now, you can go out. So if we have some slack, we say in the mechanism, okay, this number of teachers who have done at least 5 years in Créteil Versailles, I relax the constraint for them. They can be replaced by less experienced teacher, and we run the same mechanism. Then the question is how far we can go here. And at the extreme, I'm back to this, which has no constraint on the school side, right? So I know that I'm going to be somewhere in between this thing. Okay, and I think I'm done. I'm going to stop here. Thanks a lot.